Hello, I'm Matthew McNeil, the CEO of NanoAffix Science, LLC, assembling the future of sensing. And I'm here tonight to talk to you about our exciting new technology for cleaner, smarter water. Water is on our minds and in the news. And why is that? Well, Flint happened, causing millions of Americans to think every day, is my water clean and safe to drink? And clean water is important in our homes, but it's also important in the industrial context. Whether it's power generation or heavy-duty manufacturing that requires clean processed water, or clean water for the food chain, from the crops we grow to the food and beverage products that we produce and consume. To meet the growing demand for clean water, which only becomes more acute with increases in population and further demands on resources, NanoAffix has developed the water sensing technology of the future with a key set of features and benefits. What are those features and benefits? First of all, we provide real-time sensing. We can detect lead in water, but also other heavy metal ions, as well as biologic components such as E. coli, in a test that takes 30 to 60 seconds. In addition to being real-time, we provide a direct digital measurement. It's direct in the sense of no process chemicals being required, no reagents, no secondary operations, but it's also digital. And by that I mean it's based on a microchip platform and gives not only an indication of contaminants in the water, but a direct numerical measurement of what the contaminant level is. Again, because it's based on that microchip scale. That also allows the technology to be integrated. What do I mean by that? Well, two things. First of all, because it's very small, it can be directly, physically integrated into products, such as the water filter that you see depicted here. But because it's a microchip, we could also put Wi-Fi on that microchip, and it can also be integrated from a data and communication perspective. Now, when your water filter starts to fill up with lead, and your lead levels go up, we can send you a signal to your smartphone giving you that indication and telling you it's time to change your filter. That same application of the technology could be used in wastewater treatment. Imagine the Flint situation now. Our sensors embedded in all of those water pipes, pumping data up into the cloud, and someone sitting in a control room like this, and all of a sudden starts to see precipitously rising levels of lead in the Flint water system and can do something about it real time to address the problem. As opposed to what really happened, which was 9 or 12 months of Flint residents drinking contaminated lead-poisoned water. So we provide all of these features and benefits in a low-cost platform. This is technology that we've developed and that is now ready for commercialization. But I don't have to tell the people in this room, product development costs money. Well, that's what we're here to ask for tonight. NanoAffix is seeking $3 million in funding to use in 2 phases. In phase 1, we'd like to do the product development on the single-use sensor for consumers to allow lead to be tested in the home. And the second phase, the second $1.5 million, is what we consider to be the killer app for this technology, embedding our sensors directly into industrial equipment, connecting them digitally to the smart water infrastructure being developed. In addition to the funding we're asking for, we also need a good team, and we've got the beginning of that, depicted here. Dr. Junhong Chen is a distinguished professor at the University of Wisconsin-Milwaukee and has an impressive set of academic credentials. I'm the CEO, and while a patent attorney by training, I am a business development executive by passion with significant experience in technology commercialization. In addition to the right team, we have a patent pending technology. The Research Foundation has filed 2 patent applications, the second one being filed as an international PCT application as well. And NanoAffix is the exclusive licensee of the base patent and has a non-exclusive license to the follow-on technology. Speaking of the technology, what is it? Well, basically what we have here is a smart switch. A switch that not only can tell you when there's lead in the water, lead turns the switch on, but a smart switch that can also tell you the level of contamination of the lead or other contaminants in that water. And it's a switch just like the millions you're carrying around with you in your pocket in your smartphone. It's a transistor, but it's a very special kind of transistor, depicted here. It's built on a silicon substrate, and then we grow gold electrodes. The next step in the process is the key. It's the application of a semiconductor material called graphene oxide that completes the circuit and stretches across the electrodes to complete the circuit. To protect that graphene oxide, we grow a layer of aluminum oxide and then sputter gold nanoparticles onto that to make an electrical connection down to the graphene oxide. What you see depicted here is a field effect transistor, not dissimilar to others. But now we're going to tune that transistor, tune that switch, to only turn on when there's lead. How do we do that? We functionalize those gold nanoparticles with a special chemical that's uniquely designed to attract lead and to bind only to lead. Once we've created this structure, we connect it to an electrical circuit so that we can detect the signal and then expose it to lead. As you'll see, when the lead is attracted to those probes and binds to it, it causes a change in the electrical properties and turns on the switch. Watch this. So the switch has been turned on because there's lead in the water. But remember, it's a smart switch that can also tell you the concentration. In this case, the switch has communicated to a mobile phone that the concentration is 10 parts per billion. And if there's twice as much lead, we can tell you that too. In this case, with a concentration of 20 parts per billion. What's been depicted in the previous two animations is shown in this graphic. Basically, we showed the sensor steadily increasing concentrations of lead, starting very low, then going to 2 parts per billion, 20 parts per billion, and up to 200 parts per billion. And as you can see, as the concentration increases, the response of the sensor also increases, indicating not only that we can detect lead, but that we can accurately tell you what the concentration is of the lead in the water, or other contaminants, or other media. This is technology that's ready for prime time, but we can't get to prime time without your investment. Again, we're seeking $3 million in investment funding in 2 phases. The first phase, our minimum viable product, is that single-use test sensor for consumers to be able to test their lead in their homes. It would be in the form of a small handheld device similar to a glucose meter. So there'd be a handheld device with the electronics, there'd be a separate piece with a reservoir that you would pour the water into, connect them together through a USB connection, and 30 seconds later you would have your concentration. What's the market for that single-use sensor? If 1 in 10 American homes test their water twice a year, say when they change the batteries in their smoke detector, that would represent 24 million tests a year as the addressable market. We think we can successfully service, to start, 5% of that market, or about 1.5 million tests a year, and have a very viable business. Assuming we're successful in doing that and earn the right to continue to grow the company and to attract the second half of the capital we're seeking, we'll move on to phase 2 for the continuous flow embedded sensor. Again, the killer app for this technology, a sensor that lives in industrial equipment, lives in the flow, but is also digitally connected to the smart water infrastructure as that's being built out. This is an even more interesting market than the single use because it's more varied, because it's an industrial market, and frankly, more profitable. And we believe that that profitability and the success of this technology is going to begin to attract suitors. And those suitors will give us the exit strategy that we're seeking. Based on our current understanding of the market for the continuous flow devices, an understanding built in combination with the existing industrial partners who will be our initial distribution channel, we have made a projection of year 5 earnings of $8 million. Given that this is a interesting and disruptive technology, and that those companies typically sell for 8 to 15 EBITDA, and with 8 million EBITDA in year 5, you can do the calculation and begin to understand the attractive nature of the investment that we're asking for tonight. We hope that you are compelled by the possibility of that investment, but we also hope that you find the technology compelling in terms of its ability to help people and to make sure into the future that we have cleaner, smarter water. We are NanoAffix. Thank you.